This meeting is being recorded.
So, hi everyone, this is Shivakant. So today we are planning to have an open design discussion. So there is no scope defined as such, and as such there is no template or anything. This is a blank document with a door to enter. So it's all yours. So still just to give it some fruitful result, we will have some structure or layout to it. So what we can do is, probably we can collect for first 5 minutes, maybe we can collect a couple of questions like, any one of you may have, and then we will try to come up with some answers. So again, because this is open discussion, we may have, answers based on our judgment or our understanding. And this could always be countered that, okay, I don't think this is right or wrong. And then we will try to converge it to something. So again, there is no hard line that we have to be closing at a right answer, but maybe we can just put alternate ideas like, okay, this trade-off, that trade-off, probably, this path will have this benefit, other path will have other benefit, and there is no one solution to it. So basically the the philosopher or architect's favorite word, it depends. So yeah, so we can close with this as well for a couple of questions. So yeah, so let's get started. So now it's all yours. I have a blank slate. I don't have anything, unless maybe one of you can lead this thing, or one of you lead this thing. Otherwise, I'll request Shashank to lead this thing. So yeah, go ahead. Let's capture some of the questions. So yeah, go ahead, please.
Yeah, anyone can go ahead. So I have this one, right? How does this SMTP protocol works behind the email, right?
Okay, I don't know what protocol. Okay, let me capture. How does a SMTP protocol works? Okay, we will keep capturing the question. We will see, whether we are able to get the answer immediately or how. We will see. Yeah, go ahead. Next, any other question? Please go ahead. It's an open discussion. We may or may not close also. It's fine. It's like we will, see. Yeah. Anything else?
I have one. In chat applications, what kind of protocol it uses?
Okay. 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 Anything else? This is a rapid fire question round. Basically, we are capturing more and more question. So yeah, I'll autocorrect some of these, grammar and all.
I have one. Assignment of the delivery partners for the food apps.
Okay. Yeah, sure. Okay. Yeah, anything else? Go ahead. No, design is pretty broad. Typically, you can ask anything, maybe something algorithm, protocol. Just one moment. Huh? Yeah, sorry, I was away for 1 minute. Any other questions? Any other question? If someone is, if someone wants to type, okay, then I can take this. Okay, let me just copy it here, and I will. This interview specific, how do you start on any, how to start on any HLD? Okay, sure. Anything is fine. Like I said, design actually means you are designing anything. You can ask anything. So go ahead. Do you feel comfortable typing, or anything. Sorry, maybe I was away. That's why we are forced to type. So, but go ahead, ask anything. So maybe after 5 questions, we can start to come up something. Yeah. After the 5th question, we can maybe do a round of answering, or at least revisiting, so that we don't wait too much and make it boring for the rest of the folks. DB design tips. Okay. Okay, so we got 5 questions here. So let's start with this. So so the very first thing, how does SMTP protocol work? To be true, I don't know. So anyone here does they know, like, how does this work? Otherwise, I think it will require a bit of reading online and then using it, so to say.
Okay, sure. No problem.
Sure. So yeah, so we will basically need to look into it. Yeah. So I mean, I can share a quick story around it. Like I've definitely used SMTP setup and all for my project requirement. So in one of the project, basically I had done setup of Airflow where there was a requirement of notifying the end owner of a given Airflow DAG, and there actually we wanted to do, so Airflow out of the box supports integration with SMTP. So we experimented with a couple of some SMTP options were there in the org. So I experimented by as a client, basically I triggered some of the commands there, and whatever worked, I got it configured and it started working. So as a end user, I generally don't go beyond these things. But yeah, so again, like any tool or any protocol, basically protocol is more like I think a mathematical model it will be. So we'll have to go actually into it. Maybe wiki or something might help. I really don't know anything about it. So chart application, what kind of protocol does it use? So far
I have a question.
Sure.
For SMTP. So the person who asked this question, can you share your motivation to ask this question? Has this appeared in any interview, or was it part of a larger? Let me complete. Or was this part of a larger question to design something, and you felt that you didn't know about SMTP protocol? So can you elaborate on both the parts?
Yeah, so it was like, I mean, the question was, you have to design email. How does email goes from one person to another, right? The system design, the idea behind that. So basically, I was reading through a blog that they were using SMTP protocol. So I didn't had much. I didn't read it further. So I thought that let's ask it here since it was open. So that was the intent.
Okay. Yeah, so largely, okay. So in that regard, let me answer this way. I think for most practical purposes, it is not expected to know, all protocol details much for system design purpose, because for each and every protocol there are a good lot of nuances. So as long as we know that, okay, what is the use of a certain protocol, we are mostly fine with it. Like, let's say that we know SMTP is there and POP3 is there, and then there are native protocols. So we know that, let's say that POP3 is newer version. So we can say that because it is newer, I will typically prefer it over SMTP. But if SMTP works over HTTP, basically the same network protocol, then we can say that, okay, SMTP will be more flexible, and that's largely I know. I don't know beyond that. So, and you can then move on to the other part of the system design, like how the data will move, how the clients will load it. And for most practical purposes, most of these companies like Gmail and this basically Outlook, all of them actually use their some proprietary protocol only. So now it's even harder to know, and the significance also decreases, right?
I think this question is answered in a computer networks top-down approach. I have read it. How does SMTP protocol? They have a chapter on it.
Oh, okay, yeah.
So computer networks top-down approach might have that answer.
For Farooq, that book you're talking?
So it's a computer network top-down approach, crows and rows.
Yeah, maybe you can quickly open a wiki and just find out for now and just go through it. Maybe a very high level overview if that's so much I'm interested in that.
Okay.
Not a big deal,
Sure,
right?
sure,
Yeah.
sure. Yeah, let's see, because we have time, and yeah, we can do that. So let's say, so at least, first level theory, second level of like what is it, why is it, and then how is it, probably we can see to what level we are able to go as part of this discussion. So good that, it's in Geeks for Geeks. So I think this is definitely relevant. Some people must be getting asked. So simple mail transfer. Okay. Okay, so this is telling that this is application layer protocol, relay outgoing emails between sender and receiver when an email is sent and transferred over internet from one server to another. Okay, what else? Understanding the importance. As mentioned earlier, SMTP server is used to deliver transactional as well as bulk email reliably.
Yeah, if you open that Geeks for Geeks, that also is
sure. Yeah, sure. More, yeah, whatever
simpler,
is more relevant, I'll jump there because I don't know. This is something new. I'm also trying. Okay, so this is medium level. Okay, email is emerging as one of the valuable services of internet today. Okay, fine. So SMTP is application layer protocol. So this is basically the 7 layer that we were discussing. Yeah, this you actually suggested. Good. So this is basically the application layer protocol, and the client wants to send. So that means that it can use all the network layers pretty effectively. Like TCP is there, and whatever other network layers are there. It is built on top of that. So TCP connection sends the email across the connection, and is always listening mode. Okay, these are some peculiarity maybe. What else is there? Okay.
Yeah,
this is again
on 25 number port.
Yeah. So
that
okay, this is the layout, like user a terminal. So now this is a very basically a native approach. Like we have a terminal program which will connect with this protocol. It will send the transfer on this port, and then there will be another listener server which will get it here. So to me, it looks like any socket programming only. It's nothing different for me. What do you think? I mean, this is just socket programming.
So one port will be sending, the other will be receiving, right? Is it?
The server will be listening on 25 number port. That is the SMTP port.
Yeah, maybe it is.
It will be a TCP
can pull and
yeah.
push. Yeah, it can pull and push, maybe something of that sort. And on the same port 25, it can do that. So to me, it looks like some sort of socket programming kind of thing where but it runs at an application level where you communicate with the server. Server will have some sort of commands now, whether it is mentioned. Okay, so these are the commands.
4 commands. Yeah.
Mm-hmm. Oh, okay, great. So these are the commands: hello, mail, received data. And okay, it's done. That's thanks to Monica Singh. So that's all is the thing. So let's say we really want to capture it. So this is how it ends up to, and that's all. It's done. Nothing else. So what we mean is, just forget the UI, just forget all the nuances. Just think that this is just a protocol that I can trigger from command line, and something like we do telnet or we FTP, SFTP. So something of that sort, we can say that SSH we do on port 22, right? So on port 25, we will do mail transfer, something of this sort. So here, these are the commands that it supports, like identify the client server fully qualified name. Probably it will be some sort of login, and then initiate a mail transfer fully qualified. Okay, so I think if someone is interested beyond this, probably they can read it up. Yeah. So there are certain commands similar to like all of us must have used FTP, right? File transfer protocol. Like you do get, put, and whatever 10 other commands are there. So that will get the job done. So here also this will get the job done. And still, I feel that for the purpose of design distributed email system, this may not be actually needed to go to this level. Yeah, we may not need to go to this level. Anyways, like Shashank, does that answer your question? Like largely, if they are saying that okay, yeah, you design this, so what will you be using? So you can talk about, okay, I will use this SMTP protocol. I know a little bit nuances there, like, and could talk about anything beyond. We will have to build some custom protocol because this is very old. So, you know, maybe it is secure, not secure. There will be other nuances. So yeah, so let's move on. So now
Just one question.
Yeah, sure.
This SMTP server, if I want to build myself, like I have a Linux box. So what kind of software I need? Like what it can be built in a Node.js or Java, or is it something, or it's a socket programming?
Okay, so to me here this is TCP port 25. So let's say okay, how do you build this thing? Basically, a custom web server we build, right? You might have tried. Let's say I know we use any other technology we use. Let's say Tomcat or some other technology we use to build a web server. Like right now what happens is someone may ask you, hey, can you design a web server ourselves? So instead of Tomcat or any like Django or whatever Node.js you are doing, so what you will do is you will emulate this. So what does this guy do is on port 80 it listens. Okay, so there will be, on port 80, this is listening, and on that port 80, it will understand certain, certain protocol. So now that protocol will be, let's say that you will do, HTTP, basically get, post, and put. So now if you are able to implement that using socket programming, then you can basically build the whole of web server. So if you are able to build whole of web server in a similar fashion, you can build simple mail transfer protocol kind of server if you are able to just comply to all these commands. So yeah, so I think some sort of socket programming will just do here.
Okay,
yeah.
It's something like you build a microservice app or something like it keep listening
yes,
and
yes.
8080 then
yeah something like we use 8080, and here if we start supporting get, and I give you a URL now, that URL, let's say simple image downloader or resource downloader. So if you can provide something like this that listen on port 80, basically not 8080 because 8080 is custom, port 80, and you allow download of this, so you already created a web server, right? So something of that sort.
And it supports those commands, only those commands, but like
yes.
Okay.
Just support those commands. So, and the good part is all these things are totally freely available. Like you'll get numerous resources and what is expected. So you can say that I am compliant of these 3 things, but not that thing. So you can always see the exhaustive list, and of that you can say that my subset is having just three of those supports. So I'll give you an extreme example that will give you a confidence that HTML5 supported browser, right?
Mm-hmm.
Yeah, so we think that okay, all the browser are 100% HTML5 supported, but it's not like that. All browser follows some maybe out of 500 they just follow 450, 439, 657. So they have their own score, so no one is doing it perfectly. So there you can just check, so that will basically give you a confidence that hey, no one is doing full support. They had some partial support. These kind of nuances are always there. Like even the latest one will have not support everything, anything and everything. So there are some parameters to compare. How much they support. So from here you can know, okay, yeah, so here you are seeing this is like 528 maybe parameters. I hope it is some configurations basically they are supporting, but not everything they are supporting. So similarly, you can just say that I'm supporting only these. So yeah, and then get done with it. Like for example, you can say I'm not supporting security. So you'll just implement port 80. So that is totally accepted, right? So yeah. So I think we are good with this. Should we move on?
So as long as SMTP normally, I think we won't maintain any security, right? Anyone can access and push the data, like execute the command.
Yes.
Okay.
Yes. Yeah. Yeah, so that's why basically it's pretty easy to just get away with explaining too much in detail. You can say that okay, this is an older protocol. I know that we can do a lot of things from command line, but the thing is, it does not support security or latest paradigms. So I would rather concentrate on building some custom protocol here. So that way, that way you will just don't need to go into too much detail. And that also in interview format, you will not get too much time. So anyways, so we have, let's move on to the next question. So chart application, what all, protocol does it use? So what I know of is people are using WebSockets. What else? So are we doing some streaming that then probably I'm hearing people are using WebRTC if we are using some maybe video streamings, and what else can we do? So let me just search chart application protocols.
So there is SRTP protocol for streaming as well.
SRTP. Okay. So what is that actually?
Can you throw more light on WebRTC? Go ahead, I mean, WebRTC.
What is?
Can you?
Sorry, it's RTSP. So it's RTSP, real-time streaming protocol, RTSP.
Okay. Maybe I typed wrongly. This is saying WebRTC only.
So are you asking me? It's RTSP, real-time streaming protocol.
RTSP. Here I'm just doing a quick search. It is saying WebRTC only.
So this is the second one I was referring to. I told you wrong protocol abbreviation. It's not SRTP, it's RTSP.
Oh, okay. RTSP. And my screen is also shared, right? It is visible to everyone, right?
Yes.
Okay. I'll just keep it relevant to the discussion. Okay. So what is this RTSP? Would you like to share this?
It's a real-time streaming protocol. I worked on it 13 years back or 12 years back.
Oh, okay.
So it's a protocol where you can stream, and it allows you. It has method calls where it has calls where you can specify how you would pause, where to play, where to rewind.
Okay.
So like you can see protocol directives, options, describe, setup. You can get the detail of the stream that you're playing.
Okay.
So all these parameters are supported there.
Yeah. So yeah, this looks interesting, especially I think for playback, basically streaming playback, where I can basically pause and play. This looks like just for streaming. Here we can send any. So in WebSocket, I'm also curious. Like, are we allowed to just send text, or can we send multimedia as well? Like maybe binary or blob as well. So I can just check.
So WebSocket, you can send bytes.
Okay. So yeah. So if we can send bytes, then yeah. So why not? Handshake, bidirectional messages. So it is saying messages, persistent connection, and does it say bytes as well? Bytes. Okay, streamer bytes. TCP alone deals with streamer bytes. No, okay. It is saying message. So
yeah,
I think message can have.
If you can
send
load text, you can also send bytes.
Okay. So
so
let's say that. Yeah.
So WhatsApp might be using this WebSocket, right? For
yeah, maybe, yeah. That's what I keep hearing. That WhatsApp, we generally use WebSocket for this communication. So again, this is a protocol, so it will have things defined, and we can build clients now. Again, the examples we can pretty easily find. So this is what I have seen. Some languages have out of the box tools to build this thing. I think Node.js has WebSocket, very strong support for this, and other languages like Java does not have very good support or library for WebSocket. Like it is like a nail in the haystack. I was trying something a while back, maybe a couple of years back with WebSocket in Java. I was not able to find good libraries. It was some 4-year back library and all, and running that was a mess. So I think for building these technologies, we will have to also look for a language or library or framework where this is more strongly supported. And sometimes we will have to leave our comfort zone, basically my comfort zone. So yeah, so this is the text communication. This is for streaming. This is for video streaming continuous. This is what else maybe here. So again, now you start seeing here that everyone is using some proprietary protocol. So how much are we supposed to talk about it? This is always tricky, and probably the open world has not worked enough. That's why we have to the companies have to invent proprietary protocol. Okay, this is that thing. Okay, congrats whoever asked this question. You have full dictionary of things to experiment with. Enjoy.
One more
spend
item.
your night.
Yeah, one more item is probably I think they use some security. I think TLS. Probably that's something we can discuss in future class. I don't know how TLS.
Can you check what protocol does Gtalk use for communication? There was a chat tool from Google known as Gtalk.
Yeah.
Gtalk. How did it communicated text messages?
Sure.
What protocol did it use?
Gchat. I hope Gchat is.
It was Gtalk, not Gchat.
Google Talk.
Okay. I'm also trying to search.
Now, if you scroll down, there was an article which insight into Google Talk protocol.
Okay.
So do we use this now? I haven't seen Gtalk. Like first time I heard this term.
So it's not being used. It was a thing like 10 years back, 10, 15 years back, when Facebook was starting out. So this was used. It still provides you, if you have used it in your Gmail, on your left, it gives you an option to talk using Gtalk even now. So this was a Google protocol. So I was interested, how did they, I need to read it myself.
Okay. So
it used the exam protocol. Okay.
Yeah. There are so many protocols.
All these protocols, like we discussed in SMTP, we discussed about whatever that new protocol we discussed about. All these protocol will have some kind of a acknowledgement kind of mechanism will be there, right? Send and receiver, right? Or
So this will be built on top of TCP, and so it has to do two-way communication. It will so it will send and acknowledge. So yeah, that pattern it will have to apply definitely.
Okay.
Yeah.
So based on that, probably the WhatsApp chat will be make sure that the receiver is read the message and all, right, the green tick and all these things.
So it raises two questions. Does the chat first go to the server and then to the client, or directly to the chat person that you're doing?
Okay.
And how does it do that? Then the question is, how does it provide, like if there is some like communication breakdown, how does it resends that chat? Whether user has to again type that message, or does it handle out of the box? So then all these questions come.
Yeah, a lot of things.
Yeah, sure. So regarding actual communication failure and retry, what I would say is it will depend a lot on, that depends basically on the implementation. For example, if you go really back, like we were going maybe 10 years back, maybe if you go 12 years back, so there there used to be this Microsoft communicator was there, not Skype, which they bought for multi-billion dollars. So yes. Microsoft Communicator was there. So that was really pathetic. I mean, in the current world, like, you used to ping your manager, hey, I'm going on leave tomorrow, and he is offline. Okay, so he will never receive it. And by the time he comes back, you will be responded quickly that he was not available. So your message has been lost. So in those days, basically, it was like, live communication only was happening, and if you put something, the chances of getting lost was very high. Like every day, like, if I'm offline, I would not receive the messages. And like maybe 10% of the messages were getting lost. So do we have any veterans here who has faced this pain? Like,
yeah, you said it's a live messenger, right? Microsoft Live Messenger.
Yeah.
Yeah.
So what used to happen is, like, you want to get something done with your database guy, you want to get something approved by your manager, you ping him, he's not there, it is lost, and you have to come back again whenever he is online. And some people does not used to come online, and how will you send the message? So that was like, oh shit. And this is the latest that I know. Probably Slack is the latest one. I hope it's not too old. So this is like, I hope, I don't know if Discord is latest or Slack. So these have all historic messages, and you can, quickly pull, you can tag, you can do a lot of things like upload image, support these things, basically emojis. So all these things earlier, when people were sending these emojis, so it used to come as question mark actually. It used to be ASCII support only and not Unicode. And so those were also some of the nuances that the veterans would have seen.
So there's one more question. How does it sends the message to multiple chat person, or if there are multiple person he's chatting to, if he wants to send the same message, more like broadcast or gossip?
Yeah, surely. Sure. So a bit I can touch up, and maybe someone can add, and then we will move on. Otherwise, it will become chat application design question. Okay. So yeah. So let's say we are talking about one of the applications we'll have to choose. Let's say we are talking about WhatsApp. Okay, and then what could be happening there? Like we can do a best guess there. So whenever I send a message, after a couple of seconds it gives one tick, right? So it now even without the other recipient being present there, if it is able to give a one tick, it means it has to be received by the server. Okay, it has to be received by the server. Now, when the server reaches there, and then the recipient, let's say the recipient actually is online, and they are basically connected to the backend. So there will be definitely network it will require. The message basically what it does is it basically pulls or whatever through WebSocket. The message will be transferred to the recipient, and whenever it is transferred, basically it will require more workflow. But what we see is we see two ticks, right? So now again, so not only this system is not only sending the data, but it is also sending the metadata across, because tick is not by coincidence. So it has to have some, we were discussing, right? Can we send bytes? So must be either sending bytes that, okay, it got received and it got processed. So so the core thing I want to answer here is yes, it gets stored in server for most practical purposes. Yes. And how the reliability would be guaranteed is it can do a retry and idempotency at each stages. Let's say that okay, I sent a message and then it did not acknowledge. So I send my message again, probably with some ID, and then it got received. So even if it's a duplicate message, and I think they must be doing some immutability as well. So these things will, that's why you see there is no edit button in WhatsApp, right? Because we think that, okay, it is by coincidence that we don't have edit, but no edit means life is simple actually. Got it, right? So for example, let's say I create a message and then I do a hash and I give an ID. Then even if from the network is unreliable, like there are, some nuances of distributed system, and there's some better name, nuances of distributed system. So we know that, things are not reliable, okay, there's better
policies of distributed systems.
Policies, yeah, policies. Let me. So here we know that these are basically the policies. So here, the very first thing is network is not reliable. So so if we keep editing the message and we keep sending, and we don't have a way of recognizing whether this is the same message that we are sending, then what might happen is the recipient might receive both the version of message, right? So these kind of things we don't see, typically we never see, right? So either it is a hard failure that we are used to in this kind of format, and these days we don't see this kind of problem. So because it is designed for that, like WhatsApp, they don't allow edit, so it eases their developers' life. It will just send a message, then send the ID, and the caching system, whatever is there, it will always use the same ID. So even if it basically gets updated or refreshed, it's the same message only, so it does not matter. So that's how they are saving. Now the more modern system, probably Slack or Discord, how they are doing, it would be much more complicated. So the very first thing we are aligning to this. So yeah, so and regarding the broadcast, actually the simplest thing that we know of and is in Twitter design, we always talk about the fan out. So there will be multiple recipients, and probably they will have their own recipients, and probably they will have their own queue, the message queue. And what we can do is we can just during the fan out, one to many, these messages will be pumped to their queue and they will receive it. And these could be very lightweight message queue, not exactly Kafka and all. And as far as I know, like people in WhatsApp, they are using everything customized. They are using custom OS as well. So think about it. So they are building everything for this purpose. They are using some different language also. I'm just forgetting the name. It's none of the language that we use in enterprise. So I'm
Haskell.
just forgetting. Haskell or something. Yeah. So let me just check. I think Haskell or something.
They might be using an actor model.
Yeah. I don't know if I'm searching it correctly. Erlang, okay, not Haskell. So yeah, so
Erlang is actor model. Erlang is based on actor model.
Okay.
So
yeah, go ahead, please.
So I think everyone knows about actor model.
No, can you focus on that?
Yeah.
I am not aware of it. Actor model.
So actor model is a programming model which is one of the originator of object-oriented design. It works is like you have various objects which communicate by sending messages, and every object has a queue that is known that has a name, specific name. So if you want something done, you send a message, literally a message, an event which is an object, and send it to which gets queued to that object. To fulfill that object, it can do it itself, or it can create a copies of its own object and can pass that object to that. So using those messages, those objects implement some functionality, and passing those objects here and there, they're able to provide high throughput. You can even implement congruent functionality that you have. So this is a actor model thing.
So since you are using a queue, it will be asynchronous always, right? Not in sync, right?
Yes.
One object will throw a message.
Yes.
And where do we use all these things? Like in which scenarios?
It's reactive based system are all designed using this way. So there's a reactive manifesto. If you like if you want to application to scale up and down to be responsive, there are various mechanisms. So reactive programming, a reactive style of programming is one way to do it. And Akka and Erlang provide that support. They are needed for high level of congruency needs. If you have extreme, like in a typical Erlang application, you could have more than 200 to 300 threads running. It's a good language.
200 is very less, no?
200, 300 on normal machine. It's like your desktop. High level of congruency.
That also, it is very less, I think.
So this is like multi-threading kind of thing, right? Like one
it's multi-threading. It's not called multi-threading. It's called congruency. So they slight different in multi-threading and congruency. So like this is an alternative way to implement. Like the Java that we use has a shared memory model for congruency. Like you have an intermediate object where you write, you acquire that lock, one thread modifies it. Once it has done, another threads read it. So that's a shared memory model. So this is an alternative memory model, which is passing messages to each other. And then every object doing small portion of that. So it's a different way of thinking and implementing. It's a good language to practice. Like your object-oriented programming would improve substantially. It's a pure object-oriented language. If you look, this was the original idea that how should object-oriented be implemented. Erlang has.
So whenever we want to have multiple threads, right? Like for a system or parallelly, we want to execute many tasks, congruent tasks are there. So you'd prefer this, right? Actor model.
Yeah, but the breakdown of your application would be different if you think like shared memory model or message passing. Like if you implement like a bounded buffer problem you have a message producer that you have a shared queue where you write, then it blocks if it's filled, then you have a consumer that consumes over it. So you would not implement the same way in message passing.
Oh, sleep and wake state, right? Once the
so it would not be this way. It would not be implemented in Erlang. So you would have objects like one object would be a producer who would send a message to another object that would have many worker consumer working it would send a message and it can either process and sense that I'm busy, so it would send it to another object that is available, or it can keep track of which object has work done or how much speeds that they're doing, so it can offload that working to each other. So this way it's working as a balancer. Like it can also act as a load balancer. So you have multiple objects. One is producing and it's sending to another object's queue. Then it's delegating it to different object to execute. So each has its own queue and they are reading from that queue.
Okay.
Messages are queued. I would highly suggest if you get time.
We'll have to go through it.
It's really interesting.
It looks like somewhat multi-threading and Kafka kind of concept, right? Like where multiple consumers are there.
But this is like original concept. It predates both of them.
Okay. Now we'll check it, I think.
Erlang it was implemented before even Java came.
Do we use these days now also, right? I mean, wherever we want such congruency thing to implement, right? We might be using.
Yeah, nowadays it's more like React programming. They use this architecture.
So
Akka
is
a framework which implements
WhatsApp use Erlang.
I think Couchbase.
Yeah, it was invented by Ericsson.
Good.
So it was implemented by Ericsson for their high throughput and high performance network implementation. So they used extensively Erlang. They were the initial user of Erlang programming language.
Yeah, it's
So
interesting.
it was implemented in 1980s something.
Yeah, I think Couchbase in the document DB being implemented in Erlang.
Okay. Okay.
So document being like Mongo, right? That you have seen, I think.
No, sorry, key value. Key value. That Couchbase is key value, right?
Yeah.
Couchbase is key.
That is, yeah, written in Erlang.
It's just nice one.
Yeah.
So since we are
So
chat, can we even talk, right? How do we do local ordering of messages? And that's again always becomes a confusion here.
Okay. Yeah.
So let's talk about like WhatsApp storage model, right? How they store like frequent messaging, how they're like managing all those things.
What kind of
hi guys.
we are using?
Like
Go ahead.
Yeah, since we're talking about communication protocol, I think that like I have worked previously on IoT based messaging protocols because I think that is somewhat same. So there is something called as an MQTT, a message queue transfer protocol, which is kind of WebSockets. And so how does that work? Probably I can give you a small as to how does MQTT work.
Yeah, sure. Yeah.
MQTT. Not
MQTT. Okay. Sorry. My bad.
Yeah. So basically, how does?
Oh, it's MQTT or okay.
MQTT. Yeah. Okay. So how does this work? Is this basically works on a topic level concept? So something like, let's say, if I want to send a message to you, so I basically send a message to a topic, and you have to subscribe to that topic. So all the devices which is subscribed to that particular topic gets the message. So it's basically topic level messages. And how does this work? So basically there is something called as quality of service, QoS levels, which is we define it as 0, 1, and 2. So 0 basically means fire and forget. Just you can assume it to be something like those messages which are not that important. So it's kind of a broadcast message you broadcast to all people and you forget, like you don't even care whether the other person has received or not. One is basically at most.
So that right term for that is delivery semantics. This is known as delivery semantics.
Yes, in according to MQTT terms, it's called quality of service, but yeah, as you said, it's delivery semantics.
In terms of Kafka, okay.
Yeah, in terms of Kafka, but in terms of MQTT, it's QoS levels, which is quality of service.
Yeah.
And so 0 and 1 basically means at least once. That this basically means that if I send a message to you, I will at least be assured that you get the message, but you can get duplicate messages. That is quality of service 1. Then there is the highest form of quality of service is quality of service 2, which is at most like which is exactly once, I would say.
Okay.
So the 0 would be at most once. So exactly once is basically I am saying that whatever message I send, you will get for sure, and you will only get one. So these are the 3 quality of service levels which is performed. So how do we achieve all of these things? Is basically when the MQTT protocol is trying to send a message to another device or another person. So it gives an ID associated with it, and this ID is internal to the MQTT library. So you can obviously maintain one form of ID on your level, but when you send that ID forward to the MQTT packet as an MQTT packet, it defines its own ID. So if it's a QoS 0, no acknowledgement is what do you say, like is anticipated.
Record.
But let's say if you are using QoS levels of 1 or 2, then acknowledgements are anticipated. So let's say if MQTT from client A is sending to MQTT of client B, it internally maintains an ID, and the MQTT B again sends an acknowledgement to the MQTT client A with that same ID. So this is how the mapping of acknowledgement works, or MQTT knows that I have achieved QoS level 1 or QoS level 2. That is, so for QoS level 1, there is a different form of acknowledgement. For QoS level 2, there is different form of acknowledgement.
Okay.
So this is something which I had worked on very extensively. So we used Java Vertex MQTT in order to achieve, and we were able to achieve very high scale with this protocol.
Okay.
So it's not something which you can only use with Vertex. This is something which I used. So Vertex is also an asynchronous programming framework.
Yeah.
So yeah,
so I think this is similar to Kafka, right? What you talked at most once, at least once, exactly once. Same thing happened there also, right?
Yeah, exactly. It happens in Kafka, but this is a communication protocol. So Kafka is more of a messaging bus, but this is more of a communication protocol. Like WebSockets, this make persistent connections, and you can communicate how much you want.
So firing for
delivery semantics are not specific to any protocol or any messaging system. They are generic. Like these are like which guarantees that the system provides. Does it provide you at most once guarantee? Does it provide you at least once or exactly once? So this is looked as a guarantee. It's not a Kafka thing or MQTT thing.
Yeah, I feel
it's true for RabbitMQ. It's true for
we are just
any
trying
other
to
messaging
correlate
platform that would come in future.
Yeah, we are trying to correlate to understand what we have seen. Maybe we have seen Kafka and RabbitMQ, which is much more bigger and in this terminology bloated. This is very niche and just pure. It does only this thing and all this thing, and it serves the purpose. So this will be very lightweight, I think, in that regard. Kafka and RabbitMQ, they are more like a platform. They are not even library or framework. It's much heavier. Here, it could be just simple library that can be plugged both at IoT client side and server side. Anywhere it can sit, I think, right?
Correct.
Small code footprint, it is saying, and it will still provide the same set of very strong guarantees on the reliability, whatever has been talked about. Yeah.
Somebody mentioned Vertex, right? What is Vertex? It's a programming.
Vertex, it's a framework, I would say, like Drop Wizard, like Spring. So it's kind of a framework where it gives you the power of asynchronous programming, as we were talking about Erlang, where we can play with threads. So it has its own power of spawning worker threads, and basically you can say that if all my Vertex threads, if I am talking about communication, it will only wake up once it receives a message, right? So the threads kinds of is placed, and you can do parallel communication, and these threads will only get active, will only be initiated or will be active once it sees that any message is coming to my thread, right? So something like that.
It's kind of concept, right?
Yes. So now this event loop can be applied anywhere. So this basically the Node.js also this is implemented, and this is I think one of the very first implementation, and in Java the same has been implemented as part of the Vertex framework, and maybe in other languages also it will be there. So as long as the language supports a strong concurrency model and callbacks, this model can be easily implemented by someone. Yeah.
Correct.
Well, you mean to say Node.js is a Vertex programming model?
Yes.
Huh? Okay.
Yes.
I mean, very sketchily, if you say like this, because they will have hundreds of other features. Yeah. So they both support event loop, so that we can say. Yeah.
Okay. Thanks.
So here at least this part is
one
aware.
correction.
Like
spelling of vertex is not correct. It's VERTX.
Yeah. So sorry, what's written?
It is getting, I think, corrected or something. I am also getting tempted. So it's actually node or vertex. It's the same thing only, you know. It's the same thing. It is inspired from the same thing. It's about, I think they wanted to do some graph related thing, and then they name node, and from there a variant of node is vertex. So effectively, so the core concept, we should be aware about it. The language would be our choice of implementation. So what happens is actually the way to understand this is what is the traditional model. So traditional model is generally, I mean, I will explain from a language perspective because I know that way. So in let's say I'm talking about Java or Java Spring, or let's say I'm talking about Django framework. So there what they do is they create, based on your processor count and all, they will create some threads, let's say 15 threads or 16 threads. And then they will, in that thread pool, they will assign workers to process. So what happens is many a times actually out of those 15 threads, like they are just waiting for IO. They are not doing any compute. So what happens is maybe 95% of time those threads are just waiting and not doing anything. So that model actually does not fully utilize the CPU. So this in modern this alternate model where you don't just create a thread pool of things and assign things there and wait for it to complete. What you do is you have a thread pool, but you just do a compute and then you register a callback. Let's say that you want to read from a file and it takes 1 second to come back. So no need to lock the one of those 15 threads to do. What you do is you just register and you release the thread, and and once it comes back, basically then you do the compute. So that way, almost like 10-20 times or even more concurrency we are able to achieve with the same CPU, because we are not unnecessarily waiting for people, but we are asking them to come back. It's like let's say that there are two org. One org is where the employees are totally fully responsible. You tell them whenever you get blocked, come back to me. So the manager can handle many more people. But there where the employees need a lot of guidance, or there are juniors, so you'll have to always keep checking them. So effectively you are pairing with them or working with them. So this is the efficient one, where you just tell them, hey, once you are done, you come back to me. So here, the one who is orchestrating or running, their life becomes easy, so to say.
But it will open up a process or thread. I think it's open up a process, right? An event loop. Like if you're like file system, reading database is longer time. It's open.
No. So yeah, so that is so that is
it's
different.
A single
like
thread, right? It's only one thread.
Yes, this will be single thread, which will be it will be creating, I think, okay, there are worker threads are there which will do this IO and all. So it will wait for the IO to be completed. Once it's done, then it will come back to the single thread, single thread loop. Yeah. I think for maintaining the consistency, complexity, the core is just single threaded. So otherwise it will get even more complicated. Like, I mean, what I know of is very similar to this. Redis data store is single threaded. This is what I have heard, because communication between the cores, it would effectively become slow. So it doesn't want to do that. I mean, very sketchily saying. So anyways, so should we move to some other parts in the benefit of time? I think we had good number of discussion, and we discussed some really native and lightweight protocol, which serves the purpose that what we intend to do. We intend to just send messages between completely disconnected systems, and similarly, Aka or Erlang is also able to provide that kind of thing in the same machine or virtual machine or physical machine. And then we have more heavy-weighted thread and process where it shares the same memory model, so it is easier to basically understand, but probably not easy to make it concurrent. And we discussed a lot about different protocols. Some of these actually, many of these are actually proprietary because they are not able to get the best of the open source protocols that we talked about, and probably they are not extendable. That's why. So yeah, so this is, I think, largely good amount of discussion on protocols. Should we move to some other thing?
I think
Could
there
you
was
share this file as well?
Yeah, I'll finally share. So that's why I'm creating here. Yeah, that's any other ideas are there, just let me know. I'll fix it up and I will share it definitely. Yeah.
I think Perrin was.
Why do you want to get it shared, Jagan? You only contributed to it almost.
No, it's fine. Yeah, definitely. So yeah. I mean, I can immediately share the URL or PDF, whatever. So so I think I can just read-only version I can share. I think edits may not be allowed. Let me share here so that people can start reading immediately. I don't have issues. So yeah. So yeah, what else is there? Anything else you want to?
So there was a storage system, right, Perrin, you were talking about?
Yeah, storage model for messages. Okay, this looks interesting. Anyone has any idea, like for WhatsApp, or what could be?
So you missed one. There was local ordering messages before that.
Yeah.
So one of the interview, I think a couple of years back, somebody asked me like, how do you handle like multiple messages the way WhatsApp handling, right? And Twitter handling, how their storage model working, what kind of database you have to use, like, etc.
Okay.
Like it's a billions of trillions of messages, right? Terabyte of messages per day, I could say, right?
Yes. Scale is really massive, and I think only very few guys globally are able to do it. That's why they have the lead, and we don't have, I mean, there is a competition, but only very niche player are able to do it. So yeah, kind of agree there. So I mean, I think I can propose at high level, which is like whatever messages we are getting, we can just, maybe put it in a durable queue, which is basically Kafka, very naive. I'm just thinking. Next thing could be, can we put it into, like white column DB, like, Cassandra or something. Next could be, maybe we can put it in Redis. But the problem with Redis is that because it is not durable to start with, there is always a risk of message loss. So what I understand is these guys must be using proprietary thing, like so we will try to come close. I don't think we can actually come exactly to what they are doing.
So Cassandra, actually, you are storing in a DB, right? So WhatsApp doesn't store any message.
It does. So you can go back to your old message, right? It does.
Yeah, no, it doesn't.
But it only stores in your for your maybe device. That is what they say. It might be storing somewhere.
Local.
Yeah. But as per their policy, they don't store any message, and it's only you have that message. When you have it, it's deleted from the server. So,
so we use something else to store. It's Google also provide you to store it with them, the account.
Okay. Yeah. So that is basically some sort of archival.
That's good, actually. Yeah. See, if it's a Cassandra, okay, even if you're proposing Cassandra, if you go for wide column, okay, in that case, deleting will be a problem, isn't it? So I know for temporary, till the user is not online, you still have to store it in some place. You cannot store it in something like a cache.
Yes. So that would be the question.
Cassandra deleting is a problem, isn't it?
So you're saying whatever the message I have in WhatsApp, it's the memory being used for my phone itself, right?
No. What the policy is almost, but they surely store it for some time. But you have to, you're using a Tombstone, but Tombstone, is it really reliable, deleting everything and then again clearing all that? Or is it something else?
What we used for our messaging platform is a temporary, it's an in-memory database which can be persistent as well. So there is something called as Apache Ignite, which has an in-memory layer over a persistent layer. So obviously we have to use Kafka and other things in order to queue the messages and everything. But let's say if all the devices are online at that current moment, probably what we do is we save into the DB and then we submit it to the client. As soon as we receive an acknowledgement, we either delete from the DB or we either update the column saying that I have received an acknowledgement and I don't process it further. But now let's say if the devices are offline, we need to pick up the whole set of messages again and then have to retry sending it to the clients. So picking up from these in-memory databases is quite, the latency would fall down. And periodically what happens is that there is another parallel thread internally from the DB which could be helping it to persist. So anytime my DB crashes and my DB needs to come back up, it reads from the persistent store, it stores it in memory, and then we can use it as it was further.
Okay. Mm-hmm.
But
Yeah,
in
so
memory has a very small storage, right? In memory DB will have very small. In memory DB will have very small storage, right?
Yeah.
So it's a distributed in memory. We can actually cluster it out, and we can have replications and etc. for basically help in order to distribute it and scale it.
Okay.
In memory, like what?
Yeah, so similar to this Apache Ignite, I think this basically Couchbase or Aerospike might also work, right? At that level, like it is also backed by data store. I mean a disk, so it might also work. I know it may not be practical, like scale it may not support, but I'm just suggesting this could also work theoretically, right? I mean, does someone see immediately know this is something that we cannot touch? This is not immediately suitable. So here at least something got mentioned that, okay, if there is tombstone, probably, someone pull out those, dead data, or whether there is a guarantee of, no. So are there any concern that we are seeing here?
Yes, tombstone, the problem is, it might be getting deleted when it is, I think so, like the compaction and all those things happening, but still the storage part is not getting, evicted. So you're not releasing the storage back again. It might take some time, or it's not actually happening, because if you're deleting a bunch of like billions of messages immediately, you're not getting that benefit. You still keep on increasing your storage, and you need it for some time for the tombstone also. So there is some overhead in that.
Yeah, so it's fine. So my thought here is, let's say in 2 to 3 days, if all the order and received messages are consumed and processed, basically consumed and finally deleted, then it's fine, right? See, again, this will be something that we want, best effort basis, right? There is nothing like that immediately whenever the message is received. There is no EU norm which says that the same millisecond we have to delete from our system. It's a thing that no one else should be able to access it, and it should eventually get deleted. So as long as, let's say that we are running compaction automatically after 2-3 days, or we have whatever system we are using, let's say we are deleting with some nightly job or any other mechanism, as long as it does not persist for long term, I think it's fine, right? It's because even these things, basically the TTL, they don't provide guarantee. Like when I say that I have 1 day TTL, it doesn't mean that immediately it will delete on the 24th hour bell ring. It takes its own time. It is very
there is a buffer, or sometimes it will be slightly more
algorithm centric.
So in this tombstone also, what you say makes sense, but what happens, even if the 2-3 days, whatever the mark is, still some messages keep on accumulating. So at the end of a year, if you see, it is increasing exponentially. it gets deleted, but some of them will still take some time based on where in the state they are.
So, okay. So
and that is
I would
problem of, yeah, the leakage.
So that I will call leakage. So do we really see leakage? Leakage in Cassandra data model. If so, then it's something broken with Cassandra. Like when we see leakage is garbage collector, then it's the problem with the garbage collector. It is not the problem with the proposal as such. So proposal is like, I build a system, whenever I allocate 100 bytes, I will remove 100 bytes. So most likely it will work. I know in practical scenario, someone might create a static holder and it will hold everything. So that is basically developers' mistakes, right? Do you think that it is this basically tombstoning or deleting is broken in Cassandra, or because of some situation it might lead to leakage? If some situation it might lead to leakage, then we can justify with little if and but that this is what we will use with as a proposal, and this is a known caveat. Basically we can say that this is a known caveat, so to say. So this again, these are all we can try this, we can try this. Similarly here, like Aerospike or Couchbase, do we see any issues in this? Like I mean, at very high level, like no, we cannot use this. As long as this is durable, it can be used to store message for a day or two, right?
Well, okay, the point I'm trying to make here is, if not Cassandra, is there any other way to do it?
Okay. So any other alternative? Yeah, sure.
Or is Cassandra only the best way to do?
No, any database. So
which will be more efficient than this, because WhatsApp handles billions of messages every day.
Yeah, it will not scale with Cassandra.
The storage is very, very important.
Yeah, it will not scale with Cassandra. We can say that probably Cassandra will be able to take 100K QPS or something. At the billion scale, it will not scale. So we will have to think about something homemade, custom, something of this sort. So the way I'm thinking that instead of using full-blown Vertex, we use MQTT. So similar to that, instead of using full-blown Cassandra, they will create something in Erlang which will operate over disk.
Santosh, why not use Kafka, and why not use the key of the user as an ID? That would give you partial ordering of messages based on the key, and that would go to a specific topic, and you could have like 100,000 topics.
So topics will be built on what, like region?
But how searching? We need searching also, no? In that case. So will that be possible?
Searching happens locally. Search happens locally only.
Okay.
Yeah.
So
you this is just for message delivery.
So you could use the event source system. You could use the event source system to build like separating the read model and the write model. So you could use Kafka to get your events, the messages, and then if reading is like, if searching is the issue, you could build a using that read model. You could build a solution using those events in Cassandra as well. So you can use both Cassandra and Cassandra
search
and
is
Kafka.
Not needed. Search is not needed. Search
or
is
you can use Elasticsearch as well.
Elasticsearch, yeah.
No. Search is not needed. We are trying to build something else. From WhatsApp, we are jumping to Slack. So which is we don't want here. Yeah. So search is here. It will be locally. If I have the messages locally, I will search. Otherwise, I will not search.
So
yeah.
So in WhatsApp also we search previous messages.
Yeah, locally saying that is also makes sense, right? Yeah.
Yeah, so that's what I wanted to understand. This locally means what? Because if they have deleted the messages from the server, how it is getting stored locally on our mobile?
Yeah, so it will use some disk structure, and it's like the local files we create. It will create its own structure in the disk basically, and it will have let's say that, okay, the very simple thing is it can create list of messages, and then they will append it in a long file, and then they will split those files on some timestamp basis. So now whenever you want to search, it will do, I mean, as simple as it can do brute force search on those files, and again it will be proprietary format. Those files it will search, and it will be also encrypted, so all those nuances will be here for security purpose. Yeah,
if the device gets destroyed, can't we fetch the messages again? I mean, local means what, in the mobile?
If you don't back up, we cannot do. Yeah, we cannot fetch the messages. No.
So this one, who does it? This append the log. I mean file.
This is your app. This is app. App will do.
The client app will do it.
WhatsApp. App.
Or you can use a SQLite. Yeah, right. Yeah, some database. Lightweight.
So this app, basically Android iOS app, but what they will do is once they receive the message. So here till now we were discussing about a durable, transfer of message. So how does basically, durable transfer of messages we are doing. So just someone, talked about how do we do search, but actually search has nothing to do with durable transfer of message. So this is a different scope altogether.
Yeah. So two different topics.
Yeah, the two different topics. That's the thing. Yeah.
But the backup is done by WhatsApp only automatically after every 2-3 days, or like I haven't seen backup in my WhatsApp.
No, backup you can set up. No, so that is basically, I will say, maybe some sort of archival. So this is you have to enable your Google Cloud archiving, and you can manually also backup, and you can choose like I want to backup text and messages, and basically images and videos, whatever you want. Yeah. So this will
that is a different service. It's nothing to do.
This
with
is yeah. So what it might be,
where I'm during backup, where does this messages goes from our local
Google Cloud?
Google Cloud. Yeah.
iOS Cloud.
Yeah. So what it can do is, let's say that this is your local structure. So it will basically serialize the local structure and put it on the basically on the cloud, Google Cloud. So now it has to definitely, there are nuances. Let's say that what if this is new? What if this is old? What if this is new? This is old. So for single device, this is trivial. How does multi-device work? So that is another nuance. Like multi-device clients. So let's say that I have WhatsApp in 2 devices, and I try to play the same person in both the devices. So this is, I think, in beta or something. So whether any messaging system, how does multi-device client work? So let's say both are logged in as Shiva only.
But this is, let's say if somebody has to commit the crime, right? He'll commit the crime and break the phone, and the message will not, so let's say police wants to investigate it, right? So how will you retrieve the message in that case? I mean, if it doesn't do the backup, there should be something inherently being done, right? You're getting my point, right?
But that's a different feature altogether,
So, but that has to be
if you need that feature, then that feature has to be inbuilt in the app, in the system, the WhatsApp system as such.
Even if you deleted a message, right? I heard like that is recovered from your phone.
From your phone. Yeah, I have also seen. So export something like they put it in an email.
Yeah. Like that is what like most of the cops are doing in a crime. If you send somebody to message, if you delete it also, they can recover. I don't know how. So that's
otherwise anyone can do any wrong thing can be done with WhatsApp, right? Like they'll do the wrong thing.
What I think is, WhatsApp, what it does, internally they will be having some logging mechanism where in case of this is only for security, maybe somewhere in AWS Athena or somewhere they would be storing the logs, and then whenever such thing happen, they can recover from there.
No, so again, it came the point like billions of messages exchanges daily. So that much storage, like how they are like scaling.
Okay.
But it's only to a specific user we are talking about now, right?
Yeah.
No, but we don't know
No.
which user cop want. So like he has to store for all the messages.
No, from their phone.
From the phone. The user, particular person is as a suspect.
Oh,
No?
okay.
Yeah.
Okay. Mm-hmm.
Yeah, there is something, man. We need to. This is a very long, like a very tough infrastructure for them, for sure.
Okay, so this is my understanding that theoretically these guys have built a system which is not breakable, and not breakable by anyone, not even them. So this is basically their goal of ultimate privacy. Now, as part of ultimate privacy, there are always ways like your mobile is locked. If I unlock it, I can get the messages, and then if I have probably those binaries, can I get some code to decode that? So that will be additional effort. And then there are backdoors are there. So these backdoors, I mean, I'm not going to those level, but some of the government may enforce it to implement, and this is out of the books, basically they must be doing, and this is not publicized, and this is something that these spying agencies are doing. I think we should not go into that level. That's like a little sensitive to talk about. So, but the thing is, whatever is shared to the people, it is shared that it is completely unhackable, and there are no keys. But there are people who has keys. There is always some boss. So and there are other ways, like sniffers could be there, like whenever you are sending the message, like in Discord, like someone clicks on something and it gets hacked. So those kind of things could be possible, because anyway at the end of the day it's code only, right? Someone can change the binary, someone can decrypt and all. There are always ways to take out things. So typically that is not part of the intended design, but yeah, people can always hack and get things out of it. So I think we should not talk more about it. So let's close on this. Is it good for today? Maybe should we have a follow-up tomorrow or something like this on this?
I think it's almost approaching 12 in India.
Yeah. So I think we definitely had a lot of open discussion, excluding going into too much sensitive topics. So yeah. So great. Thanks everyone. I enjoyed a lot this open discussion. We got to know a lot of interesting things. I hope you guys also got to know something. So I have already shared this thing. So I'll keep making changes here. Eventually you can just consume it, and if you want, you can download it, download as exported PDF or something. And that's all. So we're done for the day. Thanks.